In this video, we're going to take a look at how to organize data by rank. So let's take a look at our table. We've got columns for employee, position, age, college GPA, and salary. So let's suppose that we wanted to find the oldest age in this list. We could just scan the list with our eyes and probably even find that it's 50 here. But suppose the list were really long, even thousands of rows. We wouldn't be able to do that, but there is a way to have Excel calculate it for us. There are a few data points that we're interested in for these particular lists. Let's start with trying to understand what the maximum is, and then we'll look for the minimum. And then let's just say we're trying to find the third largest and the fourth smallest. We'll add some formatting here to these cells to make it a little bit easier to read. And then I'm just going to copy these headers over here. To find the max or maximum in a given range, we'll just type equals max. And then we'll select all of the values in that range, which in this case is ages. And you can see that our at a glance guess of 50 was actually wrong. It's 52 as the maximum age. So if we then look at the minimum or min age, we can select that same range, close parentheses, and it's 24. Now, to find the third largest, there's actually a formula called large that allows you to find within a given array what largest number you would find, and that's what this K represents here. It's asking you which place, looking from largest to smallest, would you like me to find? And so if we type in the third largest, or 3, we'll see it's 49. And then same thing here for the smallest, the fourth smallest, we can use small. We'll select that range, and we want the fourth smallest. So this would rank it from smallest to largest. And you'll see it's 30. Now, since we didn't anchor these references here, I can actually just drag this over, and you'll see that it pulls in the correct reference here to salary in this case, or to GPA in this case. Now, since I want these number formats to match, I can use the Format Painter and drag those over. And now we have a matching format for all of our data. And we've used formulas to understand the ranking relative to one another in this data set. Now, one slight alteration that we can make to our formulas to make them even more dynamic. Let's say we didn't want to be hard coding or just typing in this 3 here or this 4 here. We can actually reference an additional cell out to the side. So what I'm going to do is I will copy these, Control C, and then down here press Control V, and you'll notice that these references are now referencing the wrong set of cells because I moved it down. So something for us to be careful about. But we'll delete this, and now let's just put a 3 here and a 4 over here. I can type in equals large, choose my array, which is just all of the ages, and then I'll reference this cell 3 to say the third largest. And if I hit F4 to anchor that, then as I drag and copy this formula over, it won't move. Same thing here, I'll use the small formula again, we'll select all of the ages. Then, just as we did before, we'll drag these cells over to the right, and we'll choose this fill without formatting, so that it maintains the number formats that it had previously. Now, if instead of saying I want to see the third largest, I want to see the fifth largest, I can type in 5, and that will change. Now, the label, of course, you will still need to change to represent the right number, fifth largest. But that's just one way how you can use cell referencing to make your formulas more dynamic and to save you time if something needs to change as you're doing your evaluation. Now, another thing that we could do if we wanted to create a numbered list to rank these largest and smallest ages, let's say that we wanted to make a numbered list. We'll start in number 1, and let's say we want to go to 8. We could drag that down, or we can use the fill series, which we've learned in another video. We can use our large formula, select the array here, and then we'll anchor it or make it an absolute reference by pressing F4. Then for the K, or in other words, which rank do we want? We want the first largest, this first column here. We'll close the parentheses, we see it's 52, and we can drag that down and it will fill in and reference. Notice we have absolute reference for this range, but then a relative reference for the rank order, which in this case goes down to 7. Now we'll give this area a title. And what if I wanted to drag this over to these other columns, GPA and salary? If I do so now, you'll notice that it gives me an error because it doesn't understand what's happening. In other words, there's no 52nd largest number in this list. It doesn't have that many rows. And this has to do with our anchoring. So I show you this just to show you that anchoring can be very useful as long as you're thinking about how you might use these formulas as you continue to drag things across or down. So here we've referenced this age range and we've made it an absolute reference for both the column and the row. If we change that to just being an absolute reference for the rows, in other words 3 through 17, now it won't move when I move cells down, but it will move columns over to the right if I drag it over. With our reference to the list number here, it will anchor in on nothing. It's completely relative at the moment. But we need to anchor just the column so that as I drag it across, it doesn't shift over to the right. So with those updates, if I drag this formula over, you'll notice that it is in fact now referencing the correct column over in this set of data, but it's remaining anchored or absolute referenced to this column H here when I reference the list. So we'll take these formulas and drag them down. And again, we can use the format painter here to keep our data looking consistent. You could do this same exercise with the small formula. For our next example of ranking, let's say that we, instead of creating a list off to the side, want to add a column into our data to give it a rank relative to the list. And we'll rank every single item in the list. To do this, we'll select some columns here, right-click, choose Insert to shift all of those formulas over to the side so that we don't lose them. They're still over here. And now we'll include columns for ranking each of these things. So one of the things that we can do with formulas, we could just type in equals rank and then use the ampersand to concatenate or combine terms. And we'll choose this right here. So now we have rank of age, and if we drag that over, we have rank of each of these other things. We'll make these columns a little bit taller, and we'll use the wrap text feature. And I like to align it to the top. Now that we're set up there, we do want to make sure that we are using the correct formula. So there are a couple different rank formulas. If I type in equals rank, you'll see there's a rank average and a rank.eq. Rank average works the way it works if there's more than one age in the list that are the same. In other words, they'll get the same rank. And the rank that is assigned to those two will be the average of those two ranks. If instead you choose rank.eq, instead of averaging the two ranks that happen to be the same, it will take the highest of the two and it will assign that rank to both of them. So we'll go ahead and start with rank.average or AVG. And it asks first for a number. That number is going to be the current row that we are on. So in this case, it would be age 49. It's a single cell. Then we'll hit comma, and now it wants to understand the reference. The reference is the whole array of ages. And so we'll select this entire array here, and again we want to anchor, but just the rows, so that as we drag across or down, the rows lock while we drag down, but the columns will shift over to the right as we move. The last thing I'll do is push comma, and it asks for the order, either descending or ascending. So we'll choose descending order, meaning that the largest number will get the highest rank. Now, we get the result of 3, which means that Alice's age is the third highest in the list. You'll notice though that it's ranked with a $sign, so we'll need to update our number formatting here. On this list, you can see a lot of different options. We'll just choose the number format, but we don't need any decimal points, so we'll remove those. And then we'll drag this all the way down. We also want to understand the rank for GPA and salary, so we can also drag it across. And since we have set up our anchoring properly, you'll see no matter where I am in the list that it references the specific row that I'm on for the number and the specific column that I'm looking at as the reference list. Now, if in our original formula we were to change this 0 to a 1, make everything in reverse order. So Frank, who is listed now as number 1, being the oldest, would become number 15. The other thing I want to point out on this age column is if we expand the decimal place just by 1, you'll notice there are a couple of these instances where it gives it a 0.5. This is because we chose the rank.average formula. So it is averaging the two places together and giving them the average of those two places. So the average of place number 10 and place number 11 would be 10.5. Now we'll do one final example as we scroll over here to the right just a little bit further, because I want to demonstrate the rank.eq formula. If I copy these formulas here by just referencing them, and I'll add a little note here that says average or AVG, and over here we'll call it EQ. I can then color code these just using the fill colors here at the top. So we'll set up our rank formula again, rank, but this time we'll use .eq. We'll reference our number over here, comma. The reference is this entire column, and remember we want to anchor the rows but not the columns. And then we'll again go with descending order. If we close those parentheses off, we copy that over, and then we copy it down. We can fix our number formatting to be the number. And this time, no 0.5s in the decimal places. You can see that we've got everything ranked equal if it happens to match. So here, this row and this row are both given the rank of 10, whereas with the AVG version of the formula, they were both given 10.5. And that's because in the .eq formula, it chooses the higher of the rank and assigns it to both rows. So that's how the rank functions work, along with the min, max, large, and small functions.